We appreciate you tuning in with us this evening. We have two topics for the evening. One is rotational grazing, and then kind of going along hand in hand with rotational grazing are some watering systems to make that possible. And our speaker this evening is Brian Freking. Brian is our Southeast District Area Livestock Specialist. He covers 23 counties pretty well from the southeast tip of the state to Oklahoma County, and then back south to Carter County or so, isn't it?
Yeah, Love County and that, yeah.
So appreciate Brian being here with us this evening. And without anything further, Brian, we appreciate you being here with us, and we're going to turn it over to you.
Thank you, Justin. I appreciate the opportunity to talk about rotational grazing. It's an area that's pretty complicated in a lot of ways, but then what I like to do is just try and simplify it so I can understand it half the time. And I do implement rotational grazing in my own cattle operation. And right off the bat, the two pictures you see with next to my ugly mug there is kind of some measurements of the forage itself. And right now is a great time to go out and measure your pastures to just kind of see what forage is available. So on the one next to my picture, it's showing somewhere between 6 or 8 inches in plant height. And the other one is somewhere around 2 inches in plant height. And so the old saying is, can that cow get a mouthful or a bite? And so typically we want them to get that mouthful. And so if we think about a ruler like we're using in this picture, if that's 6 inches in height, and we think of so much dry matter per inch, which kind of a rule of thumb, if we say 300 pounds per inch, if that's 600 pounds, or six inches times 300, we've got 1,800 pounds of actual dry matter for that cow to eat. And that's kind of the line in the sand, if you will, of a cow or stocker animal to kind of maximize its intake on a daily basis. We always estimate as a nutritionist that a cow or an animal on grass is going to eat about 2.5% of its body weight. So we have a hard time in the very early spring of the year to get that, to wait to turn on the grass. And we know we probably do at 2 inches or 3 inches. But if we could wait till about 6 inches in height, that's kind of where we're going to kind of optimize those grazing aspects. So rotational grazing is a systems approach, and we'll talk a little bit about that. So why should we choose rotational grazing? It is a systems objective, and if we look at it from the animal's viewpoint, we're trying to provide acceptable, if not maximum, animal gains and maintain forage at a high nutritional level when they're out there grazing. We hope that that grass that's out there in front of them meets their nutritional needs during critical periods of time. So if they're calving, we want to be on a pasture that's kind of providing, the amount of crude protein and the energy that, say, a lactating cow needs. So it's hopefully something we can fit into the total grazing management plan, and hopefully I'll explain that a little bit more with a few more slides here. So from the producer's viewpoints, we talked about quickly the animal's viewpoint. What about the producer's viewpoint? If we're going to implement rotational grazing, we hope that it makes us money. So this is some research done by Dr. Paul Beck, kind of in the southwest part of Arkansas, and he had this published in the Journal of Animal Science, where they looked at continuously grazed pasture and the number of days that you can get out of that versus moderate stocking rate rotation and a high stocking rate rotation. So, quickly that stocking rate in acres per cow, that continuously grazed pasture was 2 acres per cow. And at the high stocking rate, we're trying to double that and get 1 acre per cow. So obviously continuous grazing, there is no rotational grazing system implemented, whereas the other two are. And you'll kind of see there that I kind of go back to my professor. He always used to say in animal science, everything in moderation. So we don't want really big cows. We don't want really small cows. We kind of want some medium-sized cows that make our operation going. And typically moderate stocking rates the same way. So that real high stocking rate does net us that $6,000 return because we've got 12 head of cows on that pasture versus the 6 in the moderate stock ration. But probably the optimum is somewhere probably in the middle there. And so, you know, that's the trick. Knowing your environment, what kind of grasses you have, you know, what's going to actually meet your environment's going to dictate what you're going to return on these things. So let's define, you know, continuous grazing. Basically, it's the traditional way of having a pasture. We throw the animals out there on 365 days a year. They get to pick what they want to eat. You know, some of the advantages of it, of something like that. So if we think about a lease place, maybe we don't even have the opportunity to cross fence that. You know, there's going to be less time involved in that. You go check on them, but you know, moving the animals on a daily basis or every week basis, you know, we've got less time in that system. There's no allowance for deferment. What that means is we can't rest any part of that pasture or any parts of those plants that were within that pasture. So, you know, cattle like to eat the sprinkles on the ice cream first, and then they go to the ice cream that's next, and then finally they might start eating the ice cream cone, and that's kind of the last thing they finish up on. And so, you know, they're always going to go back. If Justin says, I'm going to throw a few more sprinkles on there, by God, they're going to go after them sprinkles again. So that's kind of the analogy of continuous grazing, where the animal is doing most of the selection there. Whereas when we rotationally graze, in this diagram, I'm showing 8 different paddocks, and let's say it's 360 acres. So, you know, somewhere around 40 to 45 acres per paddock. It's kind of a good number. They're going to be in there for, say, a week, maybe 3 days. And so as they rotate through those different pastures, you're resting 7 of those at any one time, aren't you? So knowledge of plant growth and plant response to grazing is critical to the grazing management decision process. And what do I mean by that? If I'm grazing Bermuda grass, my rotational grazing period of rest time between that where the cows are at to when I come back can be as short as, say, 14 days, 21 days. We may extend it out a little bit longer, but if I'm grazing native grass, which has a higher growing point, I want a rest period of a lot longer period. So maybe 45 days is kind of what I'm shooting for with native grass pastures. So we usually increase our gain per acre when we talk about rotational grazing. We increase the forage health aspect. We think that we've got those, it's kind of like running a brush hog across those pastures. We're trying to keep it in its most vegetative state, and usually that relates to better quality. We can increase flexibility. You know, when we think about legumes, a lot of times it's a legume year. Like this year, a lot of producers are telling me, man, I've got a lot of yellow hop. And sure enough, environment can play a role in what you see out in your pastures, but think of it as competition for sunlight. If those pastures are kind of uniformly grazed, those legumes have a better chance of competing with the Bermuda grasses or even some of the native grasses that are out there. Maybe we can increase our flexibility on how many of those paddocks we may actually fertilize. Instead of fertilizing that whole 360 acres, maybe we take a third of that land and fertilize every 3 years, you know, a portion of it. And so we can spread our cost over periods of time when fertilizer prices kind of go up and down. And I know they're in an up stage right now. So when we utilize better forage utilization, maybe one of those 8 paddocks has gotten ahead of us. It's gotten more mature. Maybe we can decide to say, okay, I'm going to defer that one and go ahead and cut some hay off of that. So that is still another flexibility that you have when you set up a rotational grazing system. We do have some negatives. You know, we got to think about fence. And then like Justin said, I'll finish up tonight talking about water. And so I always talk about, you know, don't let the area between your ears dictate to, you know, what's going to happen as far as implementing a rotational grazing system. So I'm hoping I'll help you out on describing what we can get accomplished with rotational grazing. There is the increase in time management. This isn't something that Justin or myself ever went to school to learn about. I will say that most of my knowledge has been going back to areas like Missouri has a grazing school. I spent a week up there learning from, the experts, Jim Garish, Ron Morrill. So, the things I say are probably dictated by some of the things I learned in those systems. And so I'm always trying to read up on, current research and implement those research practices into my own operation. So this is a chart, 1970. So there's, this has been around a long time, but it still holds true. Anytime we think about a grazing system, we can usually get the best gain per animal by having more or less a continuous grazing system. So the animal's picking out what it needs. Now, the key to that is having the proper stocking rate too. Once we start adding more and more animals and doing rotational grazing, we can get more gain per unit of land, and land is going up in price. And so that is a fundamental aspect we need to consider. If land prices keep going up and I'm trying to get as much out of my land as I can, I want to utilize the gain per acre as a goal. And so just like everything else, we can go too far one direction, and so we want to always try to strive to be in that middle. And thank God there's a range there that we can kind of live with, and usually Mother Nature dictates sometimes too what we have to fit in that optimum range. So when we experience a drought, we may need to think about destocking a certain percentage. I think we'll always need to be planning for a drought. So stocking rate, let's define that. It's a number of specified kinds of classes of animals utilizing a unit of land for a specific time period. So when we think about stocking rate, in my mind, I'm thinking about this piece of land here that's maybe guarded by 2 roads there and the fenced in area there. And so we've got 160 acres and I've got 50 cows on that 160 acres. And so how many acres per animal unit is that? We have to think about our cows. Grandpa may have had those 1,000-pound cows, but by God, today, Justin and mine are, pushing 1,300 pounds. So I've got to adjust my stocking rate based on the weight of that cow. And so we think about that animal unit as 1,000 pounds. And so if I take 50 cows at 1,100 pounds, I've actually got, more animal units there than just the 50 head that you're talking about. So it equates to 2.9 acres per animal unit. And, knowing your weight of your cows, maybe it's a stocker operation, we can come up with a stocking rate for a specific land mass. I always love to go back to a site like the Web Soil Survey and take that same picture maybe 10 years down the road to see how my grazing is done. So, maybe I changed up some fences, has the trees grown up around a creek area. I can tell you in this particular picture, we always had to reinstall a tin horn at a specific crossing point. And this is kind of where we calved out the heifers at the Kerr Center there. And we finally went to a system where we had a designed cattle crossing. And so we got rid of the tin horns, and it's one of those things that if you go to NRCS, there's some plans on how to set up those cattle crossings, or even, we used it for equipment to cross at a low point bridge there in a way. And so, there's always things to do and think about near water systems. And so this creek area was always a problem. We kind of fenced out that creek and let the trees grow up, and that kind of slowed the water down. Our main problem from this particular deal is actually the road that goes by there. They funneled a culvert across that road, and so that just it's kind of like shooting out of a big fire hose. It's going to affect how the land is basically formed downstream. So another term we need to think about that gets talked about in rotational grazing is stock density. And so that's the total number of animal units on a portion of land for any given time. And when we think about that unit of time, I'm thinking about it either a rotation period, so maybe on a daily basis, and that's usually where I keep it at. So if I've got those same 1,550 cows that I talked about earlier, and I kind of close them down with cross fencing, temporary electric fence, and I put those 50 cows on 1 acre and move them on a daily basis, I've actually now got a stock density of somewhere around 55,000 pounds per acre. And when you get animals that close together, you'll start to see that they're going to eat some plants that you wouldn't normally see them eat. And so kind of the rule of thumb Ron Morrill used to talk about, if you want to start to see cows go after weeds and such, 30,000 pounds per acre is probably that point where you start to see that. Now, if you want to kind of optimize a grazing pattern, another rule of thumb is we're probably looking at that 20,000 pounds per acre is what we would shoot for. So maybe this 1 acre needs to be expanded to 2 acres to get closer to that optimum. So Dr. Peel has a similar slide to this. Arkansas provided this data with some producers in their 300-day grazing systems and looking at how have things changed over the years, how we manage forage, how we manage the hay that we produce off of our property. And you can see that since the round baler became into existence, we have more than doubled our hay production per cow. And so that's not always a good thing. My goal is always to decrease the number of hay bales that I do feed my cows and still maintain them in a good body condition score. So I know right now it's 100, close to that 100-degree heat index. By golly, it's a little hard to go out and collect square bales like Justin and myself probably did when we were younger, right? So if we look at what research is out there, what should you expect? And continuous versus rotational grazing, can I just, cross fence my pastures and expect to increase by double? No, typically the university research is showing somewhere around 30 to 40% increases by going to rotational grazing in the cow-calf units per acre. So we can jump it up a little bit. If you'll notice in this particular 3-year study, the winning weights weren't affected. The total gain was improved by rotational grazing, like we talked about earlier in a few slides. Pregnancy rates weren't affected. And again, this shows where my goal of feeding less hay actually came into play. So we decreased somewhere around that same 30% on this particular study in Georgia. So Dr. Hovland is an excellent expert in rotational grazing and basically agronomy. And so I appreciate this little data slide here. Now, University of Florida saw similar results, and they looked into, okay, what if we rotationally grazed on a daily basis, 3 days, 7 days, 21 days? What can I afford to do? A lot of times I have an in-town job, and so maybe I can only go to that 7 days, every 7th day rotationally grazing our animals. And so looking at the University of Florida data, we can see anywhere from a 35 to 45% increase in forage production by implementing a rotational grazing system. So I'm going to throw this, I should have put it on this slide, but I didn't. The University of Missouri has a Forage System Research Center website, and it's got lots and lots of information, just like this slide that I'm talking about. So, I've shown you Georgia, I'm showing you Florida now, and again, it's kind of showing you where can I start out at. So I don't think you need to go to on a 1-day basis, especially in a cow-calf operation. 3 days or 4-day rotation is kind of what I've been doing with our research herd at here in Oklahoma. And, we're getting somewhere around 60 to 65 pounds of actual forage production of dry matter per acre per day versus if we would have just used that continuous grazing at 37 pounds there. So the picture on the right, or the slide on the right, if we think about grazing and allowing that time to rest, you know, we have that cow in there and it's freshly grazed, it's pulling off the top leaves. And so what does that do to the rest of the plant? You think about, you know, what comes off the top has got to be restored from the root system below. And so if that cow comes back and grazes that plant again, I actually think that is as overgrazing if it's not ready to replenish those solar panels that we have. And so we're always shooting for that right in the middle category where we've got good quality and quantities there. So like in my original slide, you know, man, if we could keep grass at 6 inches tall, man, we're doing good. So in a rotational grazing system, you know, what are some of the other advantages that I want to keep harping on here is that we're trying to improve farm efficiency through grazing management. So I grew up in Iowa, grew up on a grain farm, corns and soybeans. And so if I ran a combine across that land, and if I only harvested 50% of the crop, you know, Dad wouldn't be very happy. And so that's what we're trying to accomplish with these cattle as well, is improving that harvest efficiency. So by doing that, we strengthen the plants because we're allowing those plants time to rest to increase the storage of carbohydrates in the roots. It allows some of that regrowth. It increases the plant vigor. We can help with organic matter, and that'll be explained a little bit later. If you were to look at these pictures side by side, I kind of threw this in there to have you guess what time of year this might be. So the one on the left, you probably think would be later in the year, whereas the one on the right is the same picture at a different time. You know, we might think of that kind of the optimum time of the year, April or May, for example. Well, it just happened to be that this picture was taken in March, and this was actually in July. And so rainfall does dictate a lot of times, you know, how we replenish the ponds and how the grass takes up the moisture that God has given us. So, you know, just because we implement a rotational grazing system doesn't mean that we can't have to rely on Mother Nature as well. So again, looking at the percent increase when you start a rotational grazing system, it doesn't necessarily double everything. Arkansas showed a 44% increase, Georgia 37, Oklahoma 35, Virginia beat us all out of the water with a 61, but you know, maybe that's the one area that had all the rain that you could think of. So now getting into a rotational grazing system, we need to really think about it being a balance of your forage system. So when we think about in Oklahoma, what is our growing season? It's basically 160 days that are considered for, you know, ideal conditions for warm season. So when I think about warm season, I'm thinking about Bermuda grass. And right now we're definitely in the warm season start mode. Whereas back in February, we were in winter, and September and early March, we were in the cooler season part of the growing curve of the forage system. So our cool season is somewhere around 130 days. So it's a little bit less. And then we've got, especially this year, we've got 75 days that are too cold to grow on that plant. And definitely was that way in February this year, wasn't it? And so a balanced forage system, if we think about it, we're trying to have forages that are both warm season and cool season grasses, and maybe divide our property up into those systems. So even when we do have Bermuda grass, or we have fescue, for example, we can stockpile that forage maybe to cover some of those remaining days that are too cold to grow. All right, so anytime we can implement strategies to increase our grazing system, we're going to, you know, decrease the amount of hay that we're going to feed out there. So when we think about the months in Oklahoma, we're thinking about May, June, July, August, September as being the warm season months. And in that September, expect some overlap of some years where we're going to kind of claim that as a cool season environment as well. So March, April, October, November, cool season months, and then December, January, and February, that's where it gets marginal, where we see any plant growth. All right, so again, what's what's grown most here in Oklahoma. We start out with the top curve there. And when do we get the most growth out of a warm season forage? It's going to be in those warm season months. And so that's kind of a growth curve of Bermuda grass. And so we've got deficiencies back there in March and April, and again in September, October, and November. So if we implemented part of our property into cool season forages like a fescue, we can extend our grazing season by adding those forages. So the grazing system, one of the questions is, how many paddocks do I need? What's ideal? And originally for me, start somewhere. So if you've got 80 acres, man, divide that into 240s. And then once you do that, I guarantee you'll probably think about dividing those up again. But there is a point of kind of diminishing returns. And so each system, each forage component based on where you are in the state may dictate how many paddocks fit the bill for you. I'm going to say, 8 is probably a good goal to shoot for. And that's what I shoot for in my own property, is to get to that point, but it doesn't always happen in the first year. It may take 3 to 5 years to get to that point. And it's based on learning your own property and learning your own forages. And what that does is allows more rest for those plants. You can see that, when we go from having a continuous grazing at 1 there, you've got 0 rest. But if we just split that 80 acres into 240s, we've at least given those plants at least 50% rest throughout the year. And so you can see how it does get to a point of diminishing returns there when we start getting into, say, 24 or better. So my suggestion and grazing challenges for you guys is to think about diversifying your pastures, but start with what you have. So if you've already got Bermuda grass established, man, we need to utilize practices like fertility to make sure we're getting the best out of that Bermuda grass. And then if we've got some fescue, maybe it's the old original Kentucky 31. How do I dilute some of those issues? It might be something like adding clover to it. The solution to pollution, and we think about fescue toxicity, is we're going to dilute some of that original Kentucky 31 with, say, white clover. And so if they get a bite of fescue, may get a bite of white clover, we've diluted that, haven't we? And so the real trick in Oklahoma for me is to incorporate something like a legume in the summertime when it's 100 degrees out. Most of our legumes go dormant that are cool season, like the white clover. And so something like in this picture, Legend Lespedeza, in this picture, it's in the chart on the top left, it's showing Serratia lespedeza is not always a great grazing aspect plant for cattle, but it could be for goats. But this Legend Lespedeza is one of those that's been selected kind of towards cattle operations. And so kind of maybe fills in a gap. So that's what we're always trying to do is fill in gaps where we might be short in certain months of the year. So graze what you have, improve management to fill in the gaps. So if I had an ideal 360 acres, I divided it into 8 different paddocks. I'm going to start thinking about, a cow-calf operation. Where am I going to have my calves being born at? My little house down there at the bottom is surrounded by fescue. And the reason I chose fescue for that particular paddock is maybe I'm calving in March and April. So would Bermuda grass have gotten really kicked into full gear by that point, especially in March, for example? And so I want my forages near where my cattle are going to be needing it. So a cow that's just having a calf, she's going to have high nutrient requirements. I want a forage that's going to kind of match those needs. And so, we start out calving near that calving barn, and then we're going to start rotating them away from there. I'm going to maybe rotate them to maybe some ryegrass and clover, and then maybe I've planted some wheat. Get closer to the breeding season. Maybe we're in that April, May time to get the next calf crop. And then finally we get into the heart of the summer. We're going to take advantage of that Bermuda grass, or planted some crabgrass or even teff, for example. You'll notice that I do have a few other options in here, like switchgrass and big blue stem. So those are our native grasses. Indian grass would be another one. And little blue stem would be the fourth one, or the four horsemen. And for me, I kind of have a rule of thumb is I want about 25% of my land into native grasses. And the reason for that is they have deeper root systems. And so when we have those drought years like 2011 and 12, by golly, those plants survive a lot better than the improved varieties, say Bermuda grass and fescue, for example. And so I always kind of want to use those as my insurance policy or my savings account in the bank, and think about utilizing big blue stem or switchgrass as a component into my overall operation. So if I had an ideal farm system, this might be kind of what it would look like in a way. Now, it's not always easy to do that because, you know, we're going to talk about lots of obstacles like water, for example. So even within these systems, I might do some strip grazing on that wheat. You know, if it's planted every year, man, I want to harvest it as efficiently as I can. So I may strip graze that by having a temporary electric fence, by only allowing those cattle access to the far west part of that pasture, and then keep moving them to the east. And that may require maybe having mobile water in that particular pasture. So there's again, lots of things to overcome, but harvest efficiency, I still want to target my best ideal situation, even though when I get my plants established into these components. If you notice on here, how many are warm season and how many are cool season in this system. So hopefully you should notice that I've got on the top 4 paddocks, those are all warm season, and on the bottom 4 are all cool season. So I've kind of matched the whole year out by having 50-50 there. All right. You know, what about, you know, the grazing system and the time management involved? That's one of the negatives. So, you know, we can think of that as a negative, but then also think about, well, how do those animals graze across that land? What do they do as far as manure management as well? So an intensive rotational grazing system of moving cattle every 2 days has been shown to cover every square yard with manure in 2 years. A continuous grazing program will require 27 years, and more nutrients are deposited in the shade areas near or in streams or other loafing areas. So even in this picture, you kind of see this cow pox, if you will, of where the animals have defecated. And so we've got little spots, but if you get closer to the water source down there, it looks more uniform and more green down there. And that's because most of the nutrients are down at that point. And so we're trying to spread that out by how we implement rotational grazing, and it has a lot to do with the manure management. All right, so 2 other tools of grazing management. I've talked about the forage availability, and it can be as simple as going out and using a ruler, measuring the plant height, estimating that height. And so in number 3, if we're at 10 inches there in this particular case, and we say for every inch it's 300 pounds, we've got 3,000 pounds per acre there, whereas the other ones are going to be less than that. And so stock density, it's the pounds of animals per acre per day. You know, how many, the weight of the animals there's actually there to eat it. So when we think about, you know, that forage availability, you know, we know when we go to the store to buy feed, we're kind of doing the same thing of allocating how much forage is out there. We're basically pouring that feed out in front of them. This particular chart shows first grazers versus last grazers. So if that number 3 was a bunch of weedy species and you wanted to kind of get that under control, and I had goats and I had cattle in the same operations, which ones would be my first grazers? So if that number 3, I'm moving to that next, would it be the cows or the goats? And I want the animal that's going to take care of the problem plant first. And so I would probably move the goats in front of the cows. If that was forage, we had more forage in front of me, then I'm going to move the cows in front of the goats and hopefully have those last grazers pick up those plant species. So if we think about dry cows versus lactating cows, and we want to put the animals that have the highest requirement first. And so in this particular case, if I was moving dry cows, I had a group that was fall calving, and I had a group that was spring calving. The ones with the calves on would be the ones I'd move first. So in grazing management, we're always trying to accomplish some kind of assessment. And I've talked about, that forage height. And so there is some university research out there kind of giving you some guidelines to go off of. This is Iowa State's chart here of saying if I have fescue plus nitrogen, and I think it's kind of basically average forage out there, I may, for each 1 inch height, I may multiply that number by 350 or 400. If I think it's kind of, it's kind of droughty looking, I may drop that down to that fair category or even less and come up with my own number there, say 200. Obviously, fescue and legumes, that the legumes add nitrogen to those other plants, but those legumes have to die to release that nitrogen. And so it's not quite as efficient as actually applying fertilizer to the land. Bermuda grass, native grasses, they all mine nutrients from the soil at different rates, different ways. And so they do have different numbers for each one of those species. So, is there an app for this? So Dr. Rocatelli did come up with a Graze OK app that can be downloaded. And basically when you go out there and you're measuring your forage, it's a way to put those into your phone to help you come up with a final number on those per inches when you're taking kind of samples. So yes, there is an app for this. All right, so high return producers don't cheat when it comes to management. In this particular case, we're talking about grazing management. There's always ways to be better at it, and some may spend a lot of times on genetics, buying the right kind of cattle for the bulls, the cows. Some of us are better at the nutrition end of supplementing our cows, and then some of us are even better at animal health, how we manage our cattle when we do work them. And so the high return producers are basically, what I'm saying here is they don't cheat on any one of those things. And so that does include grazing management for sure. And so that's kind of where I'm going to leave the rotational grazing section. Justin, maybe open it up for a few questions at the moment.
Any questions at this point for Brian about rotational grazing?
Yeah, so I may ask you, Justin, do you rotationally graze yourself? I guess that's question number one.
Yes. Yeah,
and so his answer is yes. And what about in February? Were you still rotationally grazing, or did you have them in a dry lot situation?
We rotationally grazed through. We probably were still grazing in November, but quickly after about the middle of November, it really started to slow down, probably until the wheat and stuff started coming on, and then we grazed it a little bit. And so,
and the reason I bring that up is because I consider myself grazing year round, rotational grazing. And so even in February, when it got that cold, I was thinking ahead with the weather reports. My God, I'm going to have some hay in each one of those different pastures where all I had to do was open the gate to them. So if that tractor didn't start, by golly, I still had something for them to eat. So I still consider that rotational grazing in a lot of ways. You're not always stuck to one particular paddock, if you will. So there's a lot to think about, and this goes back to my comment. It kind of increases your management a little bit. So all right, so water is always one of those categories of, man, how can I overcome by setting up a rotational grazing system? Am I going to have to spend a lot of money to develop water? What's going to be the case? So I got a lot of my early experience by working at the Kerr Center. And if this aerial view is what we called Henson Bottoms, it's about 220 acres. We've got the Poto River there at the bottom that kind of acts as a border for a big portion of this property. And if you'll notice right there in the middle, there's kind of some roads leading to it. Those have kind of been developed since I worked up at the Kerr Center. Those are kind of oil and gas exploration. And so, this property has changed considerably over time. But basically we had water right there in the middle. And so that was kind of a wagon wheel design. And that was fed by a well that we had on the northern side of this property. And so those animals could be rotationally grazed like in a spoke system. They never actually had access to that Poto River. But if we wanted to, we could have probably had a sling pump there and pumped water to that center location if we wanted to, just off the flow of the Poto River. That is something that you do have to, get permission to do. But if no one else has claims, a portion of that, then that is one of your rights to do. Ponds are always, one of the first things that comes to mind. Off of this system here, like I said, the water was right in the middle, so that made it easy for those animals to come to the center to get to water. We had walk-through fly traps in this particular pasture, so we were kind of controlling the fly population is when they came to water. And you'll notice that there's trees along the edges here, and so that was always a good system where they went to water, and then they always wanted to go to shade in the afternoon. And so you got that grazing between both points. Not everybody has these kind of ideal situations. Now, there's some spots in this particular aerial image that's showing kind of some wear points where the cattle kind of congregate on. And off of that center, this has been developed into those tire tanks. And so now we're trying to bring the water closer to each one of those paddocks so they don't have that distance to water that we had in the original spoke and wheel design. So I think we had 100 heifers, 100, maybe as high as 150 heifers at a time. So this was kind of our heifer development piece of land when they were managing the cow herd here. So, it's kind of nice to have a border like a river where you don't have to worry about a neighbor's bull getting on you. All right, so designing a water system for future, use is sometimes a best option for beginners where you have limited funds. You may think about having temporary water systems. And so, when I think about temporary, I'm thinking about, just like a fire truck coming to put out a fire, having that system that's available. Maybe it's on an old flatbed truck or a flatbed. Actually, when I grew up with, it was a hay wagon. We could put a tank on that and move it around. And what it does is help you learn where the water needs to be. The flexibility and locating water in paddocks should be a part of any final design. So here's just one system. Kind of give you an overview. Water, in sales for a house, it's location, location, location. Well, water's the same way. Water limits the paddock design. Water will control its utilization of the grasses that you do have in harvest efficiency. And ideally, we want to have water in every paddock. Permanent water points become a focus of nutrient export and animal impact. So if we have this central location, they're going to come in to get water. They're going to more than likely hang around there for a while, defecate. And so most of your nutrients are going to stay in the same area. So if we create lanes to water, they can sometimes become sacrifice areas. Heck, we see that when we go to college and students walking across campus, they're not always going to use the sidewalk. They're going to go the shortest distance to one point. Cattle, in my mind, are no different. We see the same effects. And so you get some degradation in areas maybe you wish you didn't have by creating some lanes. So maybe one rule of thumb on a lane system, make sure it's wide enough. And 20 feet is kind of the minimum. So, if you want to go bigger than that, that allows some opportunities for those animals to kind of spread out a little bit more and don't create those lanes and degrade the land like that. So we do need to talk about what is an animal's requirements. So today, getting closer to 100 degrees, by golly, a dry cow is going to30 gallons in a day. 100 cows, we're going to 300 gallons. It's a big task to provide that much water. Dry cow, at kind of optimum conditions, can survive on 10 gallons of water pretty easily. So these are data points that have been around a long time. They seem to be working still pretty well. So we really haven't updated the amount of water that's needed by the different species. So to prevent fighting between animals, the water system must have a minimum refill rate of a ½ gallon per minute per animal. And so when we think about feedlots that start losing cattle in these heat stress environments, a lot of times it's based on that refill rate. They're all congregating, fighting at that water source, and they can't get enough water to cool off. If we think about what's the quality of water, we obviously at OSU have a laboratory where we can send a sample off to find out what the water quality is. Humans like the pH on water to be a little more tighter range of 6.5 to 8.5 on the pH range, whereas cattle can expand that a little bit more to between that 5 and 9, where it's acidic, closer to 5, and more basic when you get to the 9 category there. Total dissolved solids, or a lot of times I'll say the total dissolved salts, because that's really what we're measuring there. Anytime that's less than 1,000 parts per million, we consider that an excellent category. And so anytime we start seeing some 10,000 parts per million, we've got issues there, and may have had some animals succumb to the quality of the water. So we want to avoid those high levels of total dissolved solids, and that'll be on the routine testing for livestock watering systems. And so if you're having issues, get some help. Go to your local county extension office for some help there. So performance due to quality. There have been studies done. This one was out of Canada that looked at a dugout, and a dugout in Canada is really our ponds that we talk about here. And so the difference between water that comes to a trough, so a freeze-proof trough, we can see a ½ pound increase in our average daily gain for cows. Or calves are doing considerably better than that. Anytime you talk about animals that are drinking at a smaller amount, typically they're going to be affected a little bit more. And so when we get to steers, again, higher performing animals that are on a higher plane of nutrition or needs tend to do better when they have good quality water. So how do we get to that system of good quality? We want to think about where our water is coming from, for one, and then when we get that water, we want to put it in a location that makes good use of the grazing system. And so here's kind of a diagram. If we look at the top left-hand section there, we've got grazing movement. It's often in a circular pattern. So ideally, Jim Garish would say, man, you want to have them on a kind of a spoke system there where it's like an irrigation system. But building fence in a circle sure makes it hard to put those corner posts in, doesn't it? So you don't see a lot of that happening. We tend to use more rectangular shaped pastures. But where do I put gates in this particular case? What's the most prudent way to get cattle to move to water in the simplest fashion? And so we've got a bad gate placement on the bottom left there, because they have to go up and around to get out into that alley to go to it. Whereas the one next to it there, we say correct gate placement for movement to water. We know that water is in that far left-hand corner of the screen here. We want that gate to be the easiest access point to it. Paddocks should be similar in forage productivity, not necessarily the same size. So if we've got low-lying areas that are very highly productive, we may want to break those up into smaller size pastures. Whereas maybe we have native grass growing on top, in say arrowleaf clover on a side hill, which it tends to like to do. We may want to fence that off a little bit differently and keep those forages as a component to how we build fences. So keep paddocks as nearly square as possible for efficient fence cost. Irregular shaped paddocks have less uniform use and are more difficult to clip or harvest hay. So you know, we say we have a hay crew come in, you know, they don't always like the pie-shaped systems. And so we might want to think about, you know, about them as well. So grazing efficiency, what is the distance number that we're looking for? The University of Missouri had looked at, you know, distance from water. And ideally, we wanted about every 300 feet. But realistically, if we're going to put in pipe, we're probably going to jump out there to that 900 to 1,000 feet. You know, so if we've got a 45-acre pasture, we want that water in the middle of that 45 acres, and that would be about 900 feet on a diagonal when we actually do the math for that. And so again, this is kind of like running that combine over that cornfield, and we want to harvest as much of it as we can. So we want to at least get 50% of it. And we start getting into that 1,000 feet or worse, then they're going to come to water as a group. Okay. So how many cattle can you water out of this 100-gallon tank? Since I talked about the requirements, you know, back, let's say it was 25 gallons per animal at 100-degree day heat. You know, that's 4 head, right? And so when we got that distance to water, when the water source is near their grazing, even herd animals tend to drink individually. So we've got a 100-gallon tank. We can sure run a lot more cattle than those 4 head that we talked about originally. So anytime you talk about distance to water, think about, you know, where it's located in the pasture. The more watering points and the closer they are, the better the nutrient distribution is as well. Pond systems, you know, especially in the summer, we're trying to keep those animals from just spending a lot of time. And so we've got limited access water points to ponds that can be developed. And you can notice in this particular picture, the cattle come down to the water. They're standing on some rock that's got some support by geotextile fiber and a core there with that rocks that won't slide down into the bottom of the pond. And so those cattle don't like standing on rocks. If I go barefoot into any property, I can sure handle on the grass a lot better than I can on rocks. And so they go in, they get their water, and then they get out. And so this is one of those systems that works well to provide limited access to that pond. And what you do there is you increase the quality. You know, what happens in a drought year, you may have to extend that fence out a little bit more, but typically we tend to keep the entire pond a lot better in quality, even in the drought years. Now, one of the systems we've utilized at the Kerr Center is this siphon system. So we've actually laid pipe into the bank, run a siphon opening point into that pond. It's kind of like a 55-gallon drum that's holding that siphon out there, and then an anchor that keeps it at the water level. And basically you want to make sure it's at least 18 inches below the ice surface. And that's kind of the rule of thumb that we're searching for there. And so at the Kerr Center, if you ever get a chance to visit their headquarters, there's a big old pond there, and it's one of the main water sources for a big portion of the ranch. We've got water being siphoned as far away as a mile away. And land slope is going to dictate, you know, what kind of pipe you're going to need, what size, those kinds of things. But if I had any advice for that, to seek out some advice from NRCS to help you with, you know, they've got engineers that will help that design the pipe sizing and those kinds of things. So let's take a look at that a little bit more. You know, when we think about watering systems, so if we're siphoning it out of that pond and bringing it to a tank, you know, when we set up this tank, maybe we want to divide a pasture and split that fence with, in this particular case, it's got a electric fence going down the middle of that. So some of the negatives to that, if for some reason you've got a short and it's causing a shock in that galvanized tank, by golly, then cattle won't want to go to water very easily, will they? And so typically I like to say, let's run, say, a mesh panel across there and have that electric fence go on each side of that. I'm a big fan of the tire tanks. Notice this one's kind of half buried into the ground, so you get insulation from Mother Earth. So when it gets to be minus 15 degrees outside, those are a lot easier to break the ice on than if you had that galvanized tank that's above ground there. In this particular picture, I've got one of the negatives of this design. That electric fence is going over the top of them, but over time it kind of slacked off there, and those animals could probably lick on that and knock it down. So I like to bury that insulated cable underground. Some people prefer to make it overhead, but you're going to have to do a little better job than what's in that picture there. So when we think about a tire tank, basically all I'm doing is running piping up through the middle of that. We definitely have some YouTube videos to show you how to do that. And you've got a float system there. And so that water hits a certain level within that tire tank and stops the flow there. I like to run that pipe actually through the tire instead of in the middle like this picture is showing. And the main reason for that is like the picture with the 3 head of cattle in that tire tank. They could try and get in there and stomp on that, and they're going to break off that float valve. And so once I get that piping on the inside, it's kind of protected if an animal tried to get into that tire tank. So again, lots of different float valves you can use. I've liked the Job valves for a lot of situations, mainly because of the size to refill those tanks. So you want to be able to refill any water system pretty quickly. And again, here's kind of the engineered aspect that you might get from NRCS, kind of showing that you're going to gravel that, you're going to bury that tire tank about halfway down. You're going to put rock on each side to make a gravel pad. So Jim Garris used to talk about, man, you can set up a water tank on a mountain and cattle will still make a mud hole out of it, just with their foot action. And so you want to think about installing some of that gravel pad around water tanks. And so what happens if I need to clean this tank out? You can incorporate an outflow valve, or, kind of a release to do that. There's lots of different ways to handle a tire tank. And so obviously you want to make sure you have some kind of a shutoff valve. You don't want that water overflowing in any system. And so we want to incorporate all the adjustments we can ever have. One of the things I've not had much experience with, and mainly because usually the price of these things are a challenge to incorporate, a solar panel system. So maybe we're pumping water from a pond from far away, and all I can say about these systems is continue to check them out, because as technology gets better, sometimes these things become more efficient than you might have thought, a few years ago. So, we've talked a lot about water. Usually when we think about Oklahoma, we may think, man, those cows are suffering today. And so we've not talked much about shade. This is one of the producers I've worked with that set up a rotational grazing system, and he even came up with a shade system. Now, this particular prototype didn't handle the wind very well, and so there's always challenges to this task as well. So we tried to cover water, but by golly, there's always something around the corner that we need to figure out as well. And shade may be one of those topics that needs to be addressed at some point too. So with that, Justin, I think I kept to my hour, didn't I? Pretty good. And so I'm still open for any questions anybody may have.
Hey, Brian, I use some limited rotation grazing, and one of the dilemmas I have is when to move the cows. I seem to have a lot of uneven grazing. They may have the Bermuda graze down to 2 or 3 inches in an area, and then up to 4 or 5 inches in an area. So do I wait until it's all grazed down to a lower level, or is it best just to go with your lowest in the decision to make the move?
Yeah. So the good answer to your question or your dilemma is one of those things. This is an art just as much as a science, and so you're kind of fine tuning your art. And when do I move those cattle? And so I'm gonna probably move them quicker than the grass needs to be moved. So I'm probably gonna leave some weeds behind. Maybe using some forage that I thought the cows probably should have, cleaned up on. So here's my rule of thumb that I keep going back to. When the grass is growing fast, I move faster. And when it's growing slow, then that's when I maybe slow down and say, by golly, those cows need to stay there a few more days. And so now most cattle and most of the research is showing a 4-day rotation is about ideal, meaning that the first 3 days they're getting that 2.5% of their body weight, no problem. That 4th day is when they start, not quite getting what they need. And so it's time to rotate. Maybe for me, that's kind of when I use things like those protein tubs. Maybe if I have a 7-day rotation, I'm still okay. I know my quality of that forage is going down, and they're going to supplement themselves a little bit with those protein tubs. So I like to go anywhere from a 4 to a 7-day rotation is about as tight as I ever want to go. Okay.
Brian, we had a question in the chat, said, would you construct shade at the water tank?
Okay, so would I construct shade at a water tank? So just like my Henson Bottom example, that was ideal, having the water in the middle and the shade on the edges. So no, I would try and move my shade out, maybe away from the water source, and mainly is because what you're doing is trying to promote those cattle to move across your fields a little bit more. So it's no different than if they're not eating mineral. I may move that closer to water, or if they're eating too much, I move it away from it.
We appreciate you being here with us this evening. Without anything further, we will thank everyone and stay cool and stay safe. We'll see you later.